Good morning. Today I am going to take the topic data structures. Myself, K.S.Thilakavalli, Assistant Professor, Department of Computer Science, K.S.Rangasamy College of Arts and Science, Tiruchengode. So first we see what is data. Data is nothing but it is a collection of raw facts which includes values, numbers, measurements, etc. So here data is itself a plural form. What is the singular form of data? The singular form of data is datum. We should not tell as datas because data is itself a plural form. So the singular form of data is datum. So here this data is classified into two types. One is qualitative data and another one is quantitative data. So what is this qualitative data? Qualitative data includes a descriptive information. This descriptive information data we call it as a qualitative. Next one is quantitative. What is this quantitative data? Quantitative data includes numerical information. So how this numerical information can be included in quantitative in the sense, here this quantitative data is again classified into two types. One is discrete and another one is continuous. So what is this discrete? It consists of the whole numbers. So next one is continuous. Continuous in the sense within a range. For example, if we have 1 to 5 in the sense 1, 2, 3, 4, 5. So this range we called it as a continuous data which include in a quantitative. So next we see what is structure. Structure in the sense we are going to organizing the data, arranging the data. So organization in the sense we are going to store the data, retrieve the data, update the data and delete the data. So next we see what is data structure. So data structure is nothing but it is a particular way of storing the data in a system. We are going to tell the system how to arrange the data. So the data structure is a particular way of storing and organizing the data in a computer. This data structure can be classified into two types. One is primitive data structure and another one is non-primitive data structure. First we see what is primitive data structure. Primitive data structure is nothing but it is directly operated by machine level instructions or known as primitive data structure. What is that machine level instructions? Suppose in C program we are giving as integer. The integer cannot be understood by a system. We have to give a keyword that is int. So that level of machine level understanding instruction we call it as primitive data structure. Next we move on to non-primitive data structure. This non-primitive data structure is actually derived from this primitive data structure. Again this non-primitive will be classified into two types. One is linear data structure and another one is non-linear data structure. So first we see what is linear data structure. From the name itself linear. Linear in the sense it is nothing but sequential arrangement. So that is one by one arrangement. So in linear data structure the data elements are arranged in a sequential order. In linear we have three techniques: stack, queue and list. So similarly we have non-linear data structure. In non-linear data structure the data will be arranged in a hierarchical manner. Similarly we have in non-linear we have two techniques. One is tree and another one is graph. Let us see linear data structure in detail. The delete operation is called as pop. So the element which is placed at the top, that is the second grain, we call it as peak. So here the element which is inserted at first. So the pink element, the data element is the first element which is inserted in the stack. The first grain which is the second data element inserted in the stack, and the second grain is the third element which is inserted in the stack. Suppose if I want to remove the second grain in the sense, after removing the first grain then only I can able to remove the second grain. So the element which is inserted at the last, that will be the first element to be come out. So this stack we call it as LIFO order. So the second technique is queue. Queue is also a linear data structure. Here in queue we call it as a FIFO order, that is first in first out. The element which is inserted the first, that will be the first element to be come out. So here the data element which is added and deleted will be at the same end. So the add operation we called it as front and the delete operation we called it as rear. So this yellow color is called the first element which is inserted into the queue, and the second element pink which is inserted into the queue at the second element. So the third technique is list. List is also a linear data structure. List is also called as a sequential data structure. Sequential in the sense we are going to add the element, arrange the element one by one in a data structure. So the data element can be add and remove at any position in the list. So here this list can be divided into two types. One is array list and another one is linked list. Array list is otherwise called as static data structure because the position of each element is given by its index position. So next one is linked list. Linked list is called as a dynamic data structure. Here the collection of data elements are stored in the nodes. In linked list we have four types: singly linked list, doubly linked list, circular linked list, doubly circular linked list. So first we see what is singular linked list. So here each and every box we call it as nodes. So each node consists of two fields. So first field which is used to store the data and the second field which is used to point out the next node, that is the next box. So the first field is used to store the data. Similarly the second field is used to point out the next node. Here the first field of the first node, that is the first field of the first node, and the next field of the last node should be null. So either we can put cross mark or we can write as a null, so which indicates that it is a end of a linked list. So next one, doubly linked list. Here each and every box we call it as a node. So in doubly linked list we have three fields, whereas in singly linked list we have two fields. In doubly linked list we have three fields: the center field which is used to store the data, the previous and the next field which is used to point out the previous node and the next node. Similarly we have two links which is used to point out the next node and the previous node. So here the first field of the first node and the last field of the last node should be null, that is in the first field of this first node and the last field of the last node should be null, which indicates that it is the end of the linked list. So this is a circular linked list. Here each node has two fields. The first field is used to store the data and the second field which is used to point out the next node. So the second field of the last node should point out to the first field of the first node, which indicates that the list is in a circular motion. After the last field it should not be end, again it will be point out to the first node, which indicates that it is in circular motion. So next one, circular doubly linked list. So here each node has three fields. The first field and the last field which is used to point out the previous and the next node respectively. The middle field which is used to store the data. Here in doubly circular linked list, the first field of the first node and the next field of the last node should be point out to the first and the last node respectively, which indicates that it is a doubly circular linked list. So next we move on to non-linear data structure. In non-linear data structure we have two techniques, one is tree and another one is graph. First we see what is tree. Tree is nothing but it is a finite set of data elements. So here the data elements are stored in a hierarchical order, which is in a tree structure. The data elements are stored in a node. So the nodes are connected by an edges. So each and every circle we called it as a node and the connected line we called it as a edges. So here this is a binary tree. In binary tree we have, this is a root node and these are the child nodes. So for every parent node we have only two child nodes. So whereas in complete binary tree the same thing will be followed. So the second technique is graph. So graph is also a non-linear data structure and it is a finite set of data elements. Here the data is stored in a hierarchical order. So here each and every circle we called it as a node and vertices, these lines we are called it as a edges. This is an undirected graph because here we didn't have any arrow marks, so this is a undirected graph, whereas this is a directed graph. Suppose this is the first vertex and this is the second vertex, this is bidirectional. Here this is the first vertex, this is a third vertex in the sense from the vertex 1 to there is a path to vertex 3, but there is no path between the vertex 3 to 1 because the arrow is pointing to the third vertex. So this is a directed graph. So remaining topic of tree and graph can be discussed in the next class. Thank you.